Hi, we're continuing our foray into sequences. Today I'm actually going to combine section 8 and section 9. The book breaks it up into two. I figure you're smart enough to get it all at once and it makes the notes a whole lot shorter. But I want to first just mention yesterday with the explicit formula, the example that I did in the notes was finding the first four terms. And the point was you just take the term number, you put it in for n, and shazam, do the math, you got it. So with the explicit formula is if you wanted to find the 50th term, you just would put a 50 in for n, it'd be t sub 50, and punch it into the equation, and you got it. So the explicit formula, you just want to write there, you can jump to any term. So can jump to any term by putting the term number in the equation. And that's going to be a big difference between the explicit formula that we just did and the recursive formula is a new thing. The recursive formulas, they always have two parts. Recursive kind of has that like recurring sort of thing in the name. The recursive formula has two parts. The first part is going to give typically just the first term, the first number in the sequence. But I'm going to say gives, so recursive formula, section 8 and section 9 I should have there, gives the first and then terms. I'm going to put a little s in parentheses because it either gives just the first number, the first term. Some sequences you need to know more than one in order to keep going, such as Fibonacci's sequence, which the book hits. From there, then, the second part is it tells you how to find a term, how to find a number from the ones before it. So the second part tells you how to find a term. Typically it's going to be the 1 before it. But I'm going to put the little s in parentheses because in Fibonacci's and some other rare ones you need to have more than one term. So it tells you how to find a term from the 1 or the ones before it. In layman's terms, what that means is in order to find the second term, you use the first term and then you find the second term. To get the third, you need to know the second and do something to the second. To get the fourth, you need to know the third, and so on. So if you wanted to jump right to the 50th term with a recursive formula, it's going to take some more work in order to be able to do that. For an example then, maybe let me jump ahead a page and we'll put in an example. Maybe let's do something like 4, 1, -2, -5. So here, first thing you notice is we're going down, and each time we're going down by 3. So if we wanted to write out kind of a recursive formula for this, we would have to do something like, if we're doing the two parts, you could say, the bracket just says, hey look, here's two lines that go together in one thing. You could say if you wanted to, the first term is 4, and then you could say to find a term, subtract 3 from the one before it. Instead of the one before it, I'm going to say the previous term. Okay. That takes a while. That's kind of a pain. We could shorten that up, and that's kind of why the book has this in two sections. The first section, section 8, they kind of put in like calculator terms, and then section 9 they go through and actually do kind of the mathematical notation for it. But this first term is 4. That's fairly easy. We've been doing that for a day now. You could say something like t sub 1, so that's how we'd write the first term, t sub 1 or s sub 1 or a sub 1. Something sub 1 equals 4. And that tells us, hey, you're trying to find first term's 4. All right. Now we had our generic term, our t sub n. So if you're trying to find some generic, your second, your third, your fourth, your fifth, we did t sub n for that. We're trying to find the nth term. Well, we want to take the one before it and we want to subtract 3. The one before it, how we write that, that's kind of the problem child. That's why we have two sections for this. But there's going to be something minus 3. Well, if you want to take and kind of put that in calculator language, at least for the Texas Instruments calculators, if you're using your previous answer and then doing something to it, as you go through, it'll show up as a ANS on the screen. So section 8 goes through, and then they have ANS always stands for the number before in the sequence. So the second term, if you want to do that, you could say this T sub n, the second term, that's going to be answer, the one before, the 4, take away 3. And then that gives you the 1, the second term. If you're looking for a -2, this third number, then it'd be T sub 3. Well, that's going to be the one before it, the 1, take away 3 gives you the -2. Being able to punch these into a graphing calculator is really quite handy, so I want to quick show you how to do that. For that last sequence where we had the 4, 1, -2, -5, I don't have it on the screen. Yeah, okay, for this, if you want to type that in using the answer key, here's the easiest way to do it. First thing you do is you just take and press your 4, and you type in whatever the first number in your sequence is, then hit enter. And now you've kind of set up that if you use that answer button, it's going to show up as the number 4. And now you could, if you wanted to do answer, you can manually put it in. If you do second, then if you look up above your negative key down here, it says answer. And then a -3, enter. It'll give you a 1. So far it doesn't seem like it's helping us a whole lot, but now what's cool is every time you press enter, it'll give you the next number in the sequence. It repeats that line that you had before. So you have 4, 1, -2, -5, -8, -11, and so on. So you could use this to find like the 50th term. Just don't lose count and be off by one. It's a bummer to do all the steps and miss out on that. So I wrote a new formula here. T sub 1 equals 3, T sub n equals answer times 2. You could try to quick write it down if you wanted to, but really I'm just trying to point out how would you punch that into a graphing calculator. Show you one more time. So first thing you do is just press 3 and then enter. That sets up what the first term is. And you could go do second negative to bring up the answer, but if you take and do one of your math operations, your addition, subtraction, multiplication, division, it'll automatically put the answer in for you. So you could just do times 2, and now just every time you press enter, gives you another number in the sequence. Okay, up to the very last part now. And really the change in section 9 has to do with this ANS. That in the real world we don't write it that way. So in section 8 they try to ease you in with that. Now if you look, let me grab a different color pen here a second. Why not? Let's go here. Okay, this is always going to be your nth term. We want some way to say, okay, this is going to be the number before your nth term. Well, if n is 3, this needs to be a t sub 2, a second term. If n is 5, t sub 5, the fifth term, this has to be t sub 4, the fourth term. If it's your seventh term, t sub 7, this has to be t sub 6. So what we want to do is we want to find some way of saying, how would you write this here has to be 1 before that. And the way they do it, and this is really the hardest part, if you can get this, you're good. But you have a t sub n minus 1. And the n minus 1 is going to be the subscript. And when you do it that way, this here, when you take your t sub n, your nth term, and take 1 away from it, it's going to be 1 term before. And that's what messes people up, is when they look at this, okay, t sub n minus 1. I usually refer to that as the previous term. And really to survive this section, and it's going to come up in a couple other chapters like I said, you have to, when you see a t sub n minus 1 or a sub n minus 1, know that the n minus 1 stands for the term before. And the most common mistake is that people will say, oh, that's the term before, then they subtract 1 from that number. It's like, no, just the n minus 1, the t sub n minus 1 just means the number before in the sequence. So we could replace this whole thing here then. Your t sub 1 equals 4 says the first number, the first term in the list is 4. T sub n says to find the nth term in the sequence, you take t sub n minus 1, the previous term, the number before, and you subtract 3 from it. I want to do a couple examples, just try to drive that home, and then we are done with the sections. So my first example is going to be the sequence 7, 5, 3, 1. So if you look at that, the next number in the sequence should be Hopefully you thought about it and came up with a negative 1. Yep, because as we go through, we're just taking and subtracting 2 each time. And so to write the formula for it, you always start out with first line saying, okay, what's our first term? T sub 1? T sub 1 is going to be a 7. And then the next line, how do you find the nth term? That's going to be the one before. In Section 8, the answers that I show you in class are always going to have an ANS in there. I'd encourage you just to jump right into the habit of doing the n minus 1. So T sub n minus 1 minus 2. That's kind of the point of finding out how is it changing each time. A different example, if I do 1, 3, 9, so it can't be adding 2 each time. So if you look at that, how are they getting the different numbers? Well, to get from 1 to 3, you could add 2 or multiply by 3. Multiplying by 3 works to get to the 9, so the next number would have to be 27, which is 9 times 3. All right, then to write our formula, we'd go through and we'd say T sub 1, first term, is 1. And then the nth term, T sub n, is going to be the number before it. And in this case you do times 3. Or if you wanted to, you could do 3 times and then the T sub n minus 1. That's really kind of the gist for these. I suppose I could throw one more example in. If you have one that says, find the first 4 terms given this here, and we'll say T. Why don't I throw you one kind of like Fibonacci's? Actually, why not? This will be Fibonacci's. I said that often they give you the first term or the first terms. T sub 1 equals 1, we'll say. T sub 2, here's where I'm having the conflict. I probably should be showing you a normal one. Oh well, we'll just go with it. T sub 1 equals 1, T sub 2 equals 1, T sub n equals T sub n minus 1 plus T sub n minus 2. And now this here is going to be a recursive formula for this famous sequence, Fibonacci sequence that shows up in nature and bee family trees and stuff like that. But if we wanted to write out the first 4 terms, well, the first one is going to be a 1. That's just this top line here. It tells us, hey, look, the first term in the list is a 1. The second one then, T sub 2, our second line, also has to be a 1. And this is the part that's a little bit different, and I probably shouldn't have went here right away. But to find the nth term, you have T sub n minus 1. So if we're looking for the third term here, well, we take the 1 before it. We take the 1. So for T sub 3, this is going to be a 1 plus. Well, if n minus 1 takes you back 1 term, n minus 2 is going to take you back 2 terms. So T sub n minus 2 is going to be this first one right there. If you're talking about the third term, it's 2 before it. So 1 plus 1 gives you a 2. Applying that same thing, you could keep going. If you're trying to find the fourth term in the sequence, well, now this here is going to be the third term. So this is going to be a 2. What's the number 1 before? Plus the number that's 2 before. So 2 plus 1 gives you 3. And you could keep going from there. The next term is going to be 1 before it, the 3 plus the 2, so 5. And then the next one would be 5 plus 3 and 8, and so on. But that's an intro quick into Fibonacci sequence as well. Feel free to stop the notes. Otherwise, if you want one last, more normal example, we'll say find the first 4. And here's one that's a little bit more normal. So we'll say T sub 1 equals, we'll do 120. And T sub n equals T sub n minus 1 divided by 2. Divided by 2. So our first number in the list, and that's actually worth mentioning. A lot of people, they start out right away and they're like, 60! All excited. Happens every year on the first quiz and the first test on this stuff. But the first term is actually 120. Don't miss the obvious one, my friends. That's a bummer of a half point to lose. Okay, and then to get the next number, so we're trying to say the second term is going to be the previous one, the number before, divided by 2. So 120 divided by 2 is 60. Then the third, to get the third number, t sub n, t sub 3, you take t sub 2, the second term, and divide it by 2. So we'd have 30 and 15. And you could use that calculator trick like I showed you before. You could just type in 120, enter, then divide it by 2, enter, 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 write down the numbers, and you're done. That's it for Section 8 and Section 9. Actually, that's it for the chapter.